Dear students, let us continue the module 5. In this video, I am going to discuss the two topics, that is the sig child signal and wait PID function, and sig set jump and sig long jump function. So the sig child signal and wait PID function. When the sig child signal generates, so when a child process gets terminated or it gets stopped, the kernel will generate a sig child signal to its parent process. I hope all it is clear. When a child process gets terminated, kernel will send the sig child signal to the parent process of the child process. This is all. Now, depending on how the parent sets up the handling of sick child signal, different event may occur. So, when the sick child signal is received by the parent process, three things can happen. So, parent process can do the default action for the sick child signal. Parent process can ignore, or parent process can invoke the signal handler function. So under these conditions, we have to separately we are going to study if in each cases what all event will occur. So first case, when the parent process accepts the default action of sick child signal, then sick child, in this case, sick child signal does not terminate the parent process. It does not terminate the parent process. Then parent process will be awakened. A parent process may be awakened. API will return the child's exit status and process ID to the parent process. So as we know that whenever a child process gets terminated, the kernel will return the exit status of child process to the parent process. So API will return the child's exit status and process ID to the parent process. Kernel will clear up the process table slot allocated for the child process. So kernel will have every process will have the process table. In the parent process table, the child process status will be there. So kernel on if the child process exit, then kernel will clear the child process allocated slot from the process table. Then parent process can call the wait PID API repeatedly to wait for each child it created. Another thing can happen. Parent process can call wait PID API. The child processes create. Next, if the save mask is non-zero, then another thing can happen. The parent ignores the sig child signal. Second case, when the parent ignores the sig child signal, so sig child signal will be discarded. So because parent process is ignoring the sig child signal, so signal will be discarded. Parent will not be disturbed even if it is executing the wait PID system call. So since the parent process is ignoring the sig child signal, then parent process will not be disturbed even if it is executing the wait PID system call. If the parent calls the wait PID API, the API will suspend the parent until all its child processes have terminated. If the parent calls the wait PID API, The API will suspend the parent until all its child processes have terminated. So this is main thing. The child process table slots will be cleared up by the kernel. So this is happening in the previous case also, here also. Like whenever the child process gets terminated, the process table of the parent process will be cleared corresponding to child process data, and API will return -1 value to the parent process. Now, the third case, when the process catches the seek child signal and it invokes a signal handler function. The signal handler function will be called in the parent process whenever a child process terminates. So, whenever a child process gets terminated, a parent process can invoke the signal handler function to handle the seek child signal. If the seek child arrives while the parent process is executing the wait PID system call, the wait PID API may be restarted to collect the child exit status and clear its process table slot. So when if the parent process is executing the wait PID API, then wait PID API may be restarted. It will be restarted to collect the child exit status, and it also clears the child status from the parent process table. Depending on parent setup, the API may be aborted and child process table slot not freed. So depending on the parent process setup, API may be aborted also. Next is sig set jump and sig long jump function. Next topic is sig set jump and sig long jump. Signal set jump and signal long jump function. So these are the prototypes we have for these two functions. So sig set jump, sig jump underscore buffer environment, comma integer save mask, and integer sig long jump, sig jump underscore buffer environment, comma integer value. The sig set jump and sig long jump are created to support signal mask processing. These both functions support the signal mask processing. Specifically, it is implementation dependent on whether a process signal mask is saved and restored when it invokes the set jump and long jump API respectively. So it's all about to support the signal mask of the process. The only difference between these functions and set jump and long jump functions is that sig set jump has an additional argument. So sig jump and long jump has only one argument, but sig set jump and sig long jump has two arguments. So only difference is that. Now if the save mask is non-zero, if the mask value is non-zero, then sig set jump also saves the current signal mask of the process in environment. So sig set jump will save the current save mask in the environment. The sig long jump API is usually called from user defined signal handling function. It is called from user defined signal handling function. This is because a process signal mask is modified when a signal handler is called, and this is because a process signal mask is modified when a signal handler is called, and sig long jump should be called to ensure the process signal mask is restored properly. This is because the process signal mask is modified when a signal handler is called. When the signal handler is called, then the signal mask is modified, and sig long jump should be called to ensure the process signal mask is restored properly. And again, we must call the sig long jump, so which ensure that the signal mask is restored